Okay, a bearings question, which is really disguising, I believe, a cosine and sine question. We don't actually have to construct anything. I'm going to try and draw a picture of what I think is going on, and that should help me understand the question. So I'm at X, it says from X, so I'll start at X, I'll get my compass out, points north, it says bearing of 280. Now I'm not going to use my protractor, I don't have to be very precise, just roughly it's a bit more than 90 degrees that way, isn't it? So I'm going to call that bearing 280, and that's going to be my Y. And then from Y I get my compass out and I'm looking 220, which is a bit more than 180, isn't it? So it's going down to the bottom left as I go towards for Z. I'm just going to, sorry, I should mark on the, if I'm going 280 clockwise, that means that it's the same as going 80 anti-clockwise, isn't it? So going to Z on a bearing of 220, so it should be something like that, yeah, about there. That'll do. Okay. No, this is just a rough sketch to try and understand what's going on. Alright. So this, yeah, that's right. This angle, if I'm going to bearing 220, that means it's 140 anti-clockwise, isn't it? So that adds up to 360. So I've got that angle there. And of course, oh yes, of course, if I know, yeah, just marking that, so that's 3.5 kilometers, the other one's 6 kilometers, I should mark that in as well, probably. Okay. And what else can I can say? Well, I know that these are allied angles, aren't they? This 80, you see this 80 degrees here on the right next to X. That should tell me the angle that's on the other side, the angle which is on Y. Yeah? You see the 80 degrees, if you look at that 80 degrees, this angle here must be 100, mustn't it? Because they're allied angles. Dead end. Okay. So that means that there's 240 on the outside, which means that the angle inside must be 120. This is looking much better now. Certainly I can use the cosine rule. And what's the question wanting? It's wanting a bearing. So if I know this angle, and I know there's 80 degrees on the other side to get to the north, then I should be able, if I work at that theta, to give you a bearing to one decimal place. So here we go. I'm going to use the cosine rule to find the length opposite 120, because then I'm going to have a possibility of using the sine rule. Okay. So here we go. Cosine rule. I'll call this length I'm looking for x squared, and that's going to equal to 6 squared plus 3.5 squared minus 2 lots of 6 times by 3.5 times by cosine 120. And if I work that out, I should be able to calculate x. So, here we go. And the answer is 3. I'm a little bit surprised by that. Okay, well I think I've got x. So let's use the sine rule. The sine rule, that's going to be the unknown angle on the top, isn't it? So sine of theta over 6 is going to equal, sorry, sine of theta, yeah. Sine of theta over 6 is going to equal the same thing as sine of 120 over x. Yeah. And I'm a little bit puzzled by that. I think I've made a mistake here. If you look at my calculator, you see it's in R mode, it's in radians mode, and that's no good for GCSE. I have to be in degrees. So I need to go to shift, and I need to go to the setup on my calculator and go to the angle units and choose degrees. So that means that my work so far is all incorrect, I'm afraid. I need to do that again. Now, I know personally that there was a student who made that very mistake about 3 years ago in their GCSE, and so that means anything where they use sine or cosine or tangent was wrong. So that's worth looking out for. It should always be little d on your calculator. Alright. So just doing the cosine rule quickly, I can find that length x is actually root 277 over 2. I feel much better about that, and that seems much more realistic. Okay, good. So now I can go back to my sine rule. So sine theta over 6 is the same fraction as sine of 120 over this root 277 over 2. Okay, and so that means I can solve for theta. So I'm going to do this sine 120 divided by root 277 all over 2, and then multiply that by 6 and do the inverse of sine, and that should give me the answer I'm looking for. That's better, yeah, that's what I want. And times by 6, and inverse sine of that answer tells me that this bearing is 38, this angle, sorry, is 38.64, 38.64, which is useful because now if I'm at x and I'm looking towards z, I can do 360 take away 80 take away 38.64 will give me the bearing I'm looking for. Okay, so 360 take away the 80 take away 38.64, and whatever that comes to is the answer, and I just need to make sure it's correct to 1 decimal place. So I reckon the answer is 241.4. Okay, so I apologise for my early mistake, but that was a valuable error to have made. I did catch it, and I hope you too, if that should ever happen to you. We have to have a little d in our calculator screen. Okay, so have a quick read of that, and let's cross our fingers and hope the answer's 240. It is, thank goodness for that. Alrighty, jolly good.